All right, good morning, folks. I've got the warm up here ready to go. You guys are going to be jumping on this, so take a second, go ahead and jump on your warm up and try this out. I'll give you a few seconds if you want to press pause and give these a go before I show you how to do them. All right, let's jump straight in. If you wanted to find the mean and the standard deviation for our data, obviously we need to plug those in the calculator. So go ahead and do that. Find the mean and our standard deviation. But the really interesting question comes when we ask ourselves, well, what would happen 10 years later? 10 years later. Well, it should make common sense to us that if we go 10 years later, all of these years of experience over here for Superman and Spider-Man, Wonder Woman, Batman, and Captain America, all their years of experience has gone up by 10. So what's going to happen to the mean is also going to go up by 10. So whatever that mean was, we add 10 to it, that's our new mean. All right, our new mean would go up by 10 because everyone has earned 10 more years of experience. The question we have is, well, what about the standard deviation? Well, remember, the standard deviation measures how spread out the numbers are. So if you're measuring how spread out the numbers are, really, if everyone's numbers have gone up by 10, the standard deviation stays the same. Standard deviation stays the same because everyone's numbers went up by 10, so we're still spread out the same amount. All right, if you look at number two talks about composite versus prime numbers. That's basically just saying, can you divide anything out of them? 31, you can't divide anything out of 31, so that's called a prime number. 24, we definitely can. You can divide 2 or 3 or 4, lots of numbers, so that's called a composite number. And then last but not least, 57, that might look prime to a lot of people, but it's not. You can divide that by 3. If you divide by 3, you end up getting 19. So that's also a composite number. That'll be important for later on today. All right, last but not least, if you look at number 3, you're asking yourself which of these has a lower standard deviation? A lower standard deviation. So which one of these frequency tables has data that's closer together? And in this particular case, the lower the standard deviation is going to be tied to high frequencies in the middle. So notice we have very high frequencies in the middle of our graph versus in graph B, very high frequencies on the ends, the beginning and the end of our graph. So the lower standard deviation in this case is actually graph A. The higher standard deviation is going to be where we have these two columns splitting down on the left and the right, and we have all this empty space in the middle. So this right here would have a very high standard deviation, a much larger standard deviation. So very important to be able to determine those things from a graph as well. So that's your warm up. Let's go ahead and finish that up, and then we'll jump into today's notes.